For number 38, this question, it is asking us to write a balanced half reactions for the process first. So if we look at the net ionic equation, which is already given in the problem, first we'd identify the which element is going through reduction, which is going through oxidation. So if we look at here, 2Se 2 minus, it turns into 2Se solid, which is going from 2 negative to a 0 charge, which means it lost 2 electrons, meaning that it's going through oxidation. So we put it down. Since it's both 2 as coefficients, they cancel out, and it comes down as Se2 minus turning into Se solid. This one is aqueous. Okay, then we identify the other ones. For 2SO3 2 minus, it turns into S2O3 2 minus. Well, they're both 2 minus for the charge, but there are 3 O's here, and it's -6 in total, because per oxygen there is -2 charge, so which means the S here has a +4 charge, while here it's 2 sulfur and 3 oxygens. Well, the oxygens remain the same, which is -6, but the sulfur has 2, which means they only have +2 per sulfur, meaning that they gain 2 electrons. So this is a reduction reaction. And for the water and the 6OH here, well, if you look at it, the H has a positive charge, but come here it became a negative charge, meaning that it gained an electron, so it's also a reduction process. So we put the 2 reduction reactants together. So it comes down as 2SO3 2 minus plus 3H2O to 6OH minus plus S2O3 2 minus. Okay, so now we come down to balance these 2 equations. First, here if we look at Se2 minus, go to Se solid. Well, the number of Se's are the same. We just need to balance the charge. Okay, meaning that we need to add 2 more electrons on the right side, because this is a -2 here and there's the 0 charge here. So we need to balance that, make them both -2. And in the second half reaction we have here, we have 2 sulfur. Okay, so sulfur check. 3 oxygens, 6 oxygens, and 6 oxygens, 3 oxygens. Okay, so no, actually 6 oxygens, 3 oxygens, 6 oxygens, 3 oxygens. So the oxygens are the same too. And if you look at hydrogens, there's 3 hydrogen, and there's 6 hydrogen, and there's 6 hydrogens. So the hydrogens are also the same amount. So when all the major elements have the same amount, now we just have to take a look at the charge. It has a -4 here because 2 times -2 is -4. 0 charge, -6, and -2. So it has a total of -8 on the right side and -4 on the left side, meaning that we need 4 more electrons on 4 more electrons on the left to balance the charge. Okay, so this is the end of the half reactions for the process. So if we clean it up, it would just be Se2 minus aqueous to Se solid plus 2 electrons, and the second half reaction would be 2SO3 2 minus plus 3H2O plus 4E minus 2 6OH minus plus S2O3 2 minus. That's our result for part A. And now for part B, since we're already given this 0.35 voltage, we are trying to find the standard E for SE. Oh, okay, so it's, remember we figured that the Se is going through oxidation, which means it's the cathode. So it's the cathode minus the anode, which give us the final voltage. So if we put it in the cathode, we don't know because it's not given in the problem, so that would be X. And then the sulfide, which is the anode, because undergoing a reduction process, a reduction reaction, so it is minus negative 0.57, turning into the given number 0.35. So now we got X plus 0.57 equals 0.35. And X would be 0.35 minus 0.57, so X is 0.22, which is the results for part B.